Okay, in part one of this video, hopefully you've watched that now, I went through kind of some of my certainties. Alright, just to point out as well, okay, one thing I possibly did mention, possibly didn't, is if you want to look at the sine and cosine rule anymore, it's booklet D, part 2. If you want to have a look at the quadratic equation, it's in booklet E. I'm not quite sure what part, okay, but everything I do in this video, I'll hopefully try and reference it up to another video just in case you want to go there. Alright, what am I expecting this to look like? Somewhere near the start of this video I'm expecting some basic algebra skills, expanding, factorising, solving, right? Let's have a look at this one here. X over 2 plus 18 equals 26. To leave x by itself, what do I need to move? The plus 18 to be minus 18. 26 take away 18 is 8, and then the opposite of dividing by 2 is to times by 2. Make sure you get rid of loose things like plus 18 or minus 18 first, and then whatever, say x has been divided or times by something, do that second. The only time you wouldn't do that is if it was x plus 18 over 2 equals 26. That slightly changes it, okay? Because it's all being divided by 2, the first thing that would move in this case is the divide by 2. Then the plus 18 would go as minus 18. So it does slightly change the order. If the thing is loose, it goes first. If the thing is part of what's being divided, it goes after, and the divide goes first. Expanding some brackets, y times y squared is y cubed, and y times 4 is 4y. Solving an equation with x's and numbers on both sides, you've got to get the x's one side, so I'm bringing the 3x over, plus 3x coming over as minus 3x, and I had a minus 65 here, the opposite of minus 65, take that over, plus 65. 5x minus that 3x is 2x, and what was there, minus 17, add on 65 is 48, 2x is 48, so x is 24. Another little one like that, plus 12 goes over as minus 12, 28 minus 12 is 16, and then the divide by 4 becomes times by 4, 64. Okay, and if you get a factorise on a page like this with your basic factorising is into one bracket, so you're looking for the biggest number that goes into the numbers and any letter that will go into both things. So what I picked out here was the biggest number that goes into these is 2. But there's also, this is x times x times x, x cubed, but this is x times y, so there's an x in both. That can also come out. Once you've picked out that biggest number and any letters that can come outside, single bracket and work out what do we have to multiply that by to get back to this. What do we have to multiply that by to get back to this? Well, to get the 8, I need 2 times 4, and to get the x cubed, I need x times x squared. That's the first one. To get 2x to become 2xy, well, the only thing missing is the y, so I need 2x times y to give 2xy. So I'd expect a page of that basic algebra, right? Further on in the paper, you might be asked to factorise some things that are a little bit harder. For example, factorise something that is a quadratic. Now, in the first part of this video, we talked about solving quadratics with the formula late on in the paper. But if they specifically say factorise, then you've got to factorise. And I always like to remember team. You're looking for two numbers, the times to give the end number, in this case minus 21, that will add to give the middle number, in this case minus 4. So I've done a little table, two numbers that are going to times to give me minus 21 and add to give me minus 4. There's a couple of pairs that will give me the 21. I've kind of ignored the fact that's a minus. I'm just going to make sure I concentrate on that negative there. So I've got 1 times 21 and 3 times 7. The only pair that will give me the 4 I need, or the minus 4, is this. Now, if that were plus 4, I'd be doing 7 take away 3. But because that's minus 4, and that is vital, I can't stress enough how getting the sign of that right, it's 3 take away 7. And these numbers, the 3 and the minus 7, go straight in to brackets then. One with x with the plus 3 and x with the minus 7. That's the factorising done. If that's all it wanted, I could stop. But if it says equals 0 and says and hence solve, I've got to go on and say, okay, now I know this bracket times this bracket equals 0. Either this bracket is equal to 0 or this bracket is equal to 0. Make sure you write either or. Okay, giving me the two answers, x equals minus 3, take that over, or x equals 7, take that over the other side. Okay, I'm going to miss that and go down here. All right, we've done factorising into a single bracket. We've done factorising into a double bracket here. The only other type of factorising that might come up is the dodgy one. It's the one that's quite hard to spot, called the difference of two squares. Something like, even it's easiest, it's x squared take away 49, and you'd spot, hang on, that's x times x, and that's 7 times 7, and it's a difference of two squares. And in that case, to factorise it, you put x plus 7 in the first bracket and x minus 7 in the second. So what I've got here is something that actually doesn't say factorise, it says simplify, but hopefully you'd spot with when you're simplifying a fraction like this, hang on, maybe I could factorise these. And the top is 49x squared, which is 7x times 7x, and 100, which is 10 times 10, so it's the difference of two squares. 7x plus 10, 7x minus 10, two brackets. The bottom also needs factorising, if you got one of these, okay? But into it, well, it's not a quadratic, it's not a difference of two squares. The only thing I can do there is just do what I did on that last kind of example back here. Alright, is single bracket, is take out the biggest number or any letters I can. And in fact, all I can take out of 14x plus 20, the biggest number that goes into those is 2, and it leaves me with 2 lots of 7x plus 10. But you can see I've already then identified, I've got a bracket on the top, bracket times bracket, 2 times bracket, and these are the same bracket, so it can be cancelled to leave that. Now, you had to do algebraic fractions in paper 1. Where you had to make two fractions into one, but just in case, but I wouldn't overly worry again on this. If you had something like this, the way I do this, there are other ways, is I do the bottom of that times the top of that, so 8 lots of that, which I've written there. The bottom of that times the top of that, so 4 lots of that, which I've written there, with a plus in between, okay? Divided by that times that. So that times that, plus that times that, divided by that times that, and 4 8s are 32. But we've got this being equal to a half. So, because I'm solving, that divide by 32, I'm going to take up there as times 32. I'm then going to collect together things. 8x add 8x is 16x, and minus 56 add 20 is minus 36. So it leaves me, once I kind of move that up there and simplify this, with 16x equals 52, being that, which is 16, add the 36 from there. So x is 52 over 16. Now 16 doesn't go into 52, but grab your calculator and maybe give your answer to one decimal place. So yeah, so there could be that some basic algebra and some factorising, maybe some double brackets or some single brackets, or maybe a difference of two squares. Okay. A little question about two dice. Okay, if I roll two dice, every combination of two numbers has a 1 in 36 chance of happening. If there are more than one combination that can get me what I want, for example, how many combinations get me a total of 6? Well, there's 1 with a 5, 5 with a 1, 3 with a 3, 4 with a 2, 2 with a 4. Every single one of those has a 1 in 36 chance of happening. So the probability of getting a total of 6 is 5 out of 36, 5 different combinations. Whereas if it's a dice with a coin, every combination has a 1 in 12 chance of happening. 6 things on the dice, 2 things on the coin. Venn diagrams, I'm not going to say anything about. I think you should be okay. Pythagoras we did in video 1. Simultaneous equations, right. Hopefully you're just given the simultaneous equations, okay, and it'll say solve these simultaneous equations, or find x and y for these simultaneous equations. That's the best case scenario. Worst case is you get something quite wordy, okay, and they don't even say simultaneous equations. What they tend to use is the phrase use an algebraic method, all right. And you'd have to spot, hang on, I've made myself two equations here. For example, what I'm told in this question, we've got flower bed A, which is x meters long and y meters wide and has a perimeter of 18. I got flower bed B, which is twice as long, so 2x, and 3 meters wider, so not 3y, y plus 3, whatever that is, add 3 meters wider. But this one has a perimeter of 34. So equation 1, y plus x equals 18. In other words, 2x plus 2y equals 18. 2x plus 2y equals 18. This one, 2x plus y plus 3 plus 2x plus y plus 3 equals 34. So I end up with 4x plus 2y, but also from that plus 3 and the plus 3 there, you get a plus 6 equals 34. And that number then needs to go over with the number on the other side as a takeaway. 34 take away 6 is 28. So my two simultaneous equations are these two. First job is to make these the same. In this example, I don't need to do anything, they're already the same. So I look at the signs. If both are positive, I write same signs subtract. If I had a positive and a negative 2y, I would be writing different signs add, not the case here. Okay, same sign subtract. 4x, now I'm going to do bottom take away top because my bigger numbers are on the bottom. 4x take away 2x is 2x. 28 take away 18 is 10. 2x equals 10, so x equals 10 over 2, which is 5. Then pick one of your first equations. I'm going to pick that one and write it again. 2x plus 2y equals 18. The only difference this time is I know that x is 5. So instead of 2x, 2 lots of 5 is 10. So 10 plus 2y is 18. That 10 then can go over as a minus 10. 18 take away 10 is 8. 2y equals 8, so y equals 4. Now, I didn't read the question first time I did this, but the question actually says, what is the area of the two rectangles? So I've actually got to go back to the beginning now and work out the areas. So the area of A, as we see, A had a length of x and a width of y, but x we now know is 5 and y is 4. So the area of A is 5 times 4, 20. Whereas this one had a length of 2x, but if x is 5, that's 2 lots of 5, which is 10, and a width of y plus 3. Well, if we worked out y to be 4, 4 plus 3 means that is 7. So the area of that is 7 times 10, which I've worked out down here to be 70. So always read what the question wants, but if it says that, use an algebraic method, the chances are we're looking at trying to form two simultaneous equations. If you're not happy with the difference between same sign subtract and different signs add, go back to booklet, whatever booklet it's in. I'm going to say E. In fact, I'm pretty confident it's E. I'm not sure which part, but you can have a little look. Okay. Done the algebra. Okay, let's do some straight line graphs. Okay. For any straight line graph, the equation of the line looks like that. Y equals mx plus c. Okay, where the number before the x, m, would be a number. That number represents the gradient. Okay, if that number is positive, the gradient is the line is going up. Okay, if that number is negative, it's going down. The c is where it cuts through the y-axis, which is this here. So what I've done on here is I've labelled, this is what c is, this is what this number that goes there, okay? Whereas to find m, I'd have to work out the gradient, and I work out the gradient by drawing a little triangle somewhere along the line and doing the rise divided by the run. Be careful with the one I've drawn here actually though. When you do rise divided by run, make sure that you put a minus for the answer because it's a negative gradient. If it was going up, it would be positive. Let's say that this is 8 and this is 16. Okay, then the rise over the run would be 8 over 16, which is 0.5. But because it's going down, the gradient is minus 0.5. So apply it to a question. We're told this line is y equals 7x plus 2. What does that mean to me? It means that it cuts the y-axis at 2. It means that the gradient, the rise over run is 7. Okay? So, for every step across 1, this thing is going up 7. 7, rise over run, 7 divided by 1 is 7. Okay? My two questions are, what is the coordinate of the point A? Well, we know it's 2, so it's 0 across and 2 up, so 0, 2, as opposed to 2, 0. Then, an awkward way of asking this, but it says, if h is 1, what's the value of k? Well, in other words, if we go across 1, how much have we gone up? Well, it's just a strange way of saying what's the gradient. Rise over run, so it's 7, okay? Another thing we quite like piling in with these questions is parallel lines. Okay, in order for lines to be parallel, they must have the same gradient. Okay, now I've changed this question to parallel. So what here is parallel to y equals 7x plus 2? Well, 7x plus 3, that's a good start. Same gradient, 7, different y-intercept, that's parallel. X over 7 plus 3, no. Minus x over 7 plus 3, no. 2x plus 7, no, different gradient. I need different gradient. This one's, I've added this one myself, just be careful. If it says 2y equals something, before you say, oh, 14 is the gradient, that's the number before the x, no, you can only say what the gradient is when you've got y equals. So what I'd have to do here is go, no, that 2 needs to come over and we've got to divide these by 2. So I half that and I half that. I divide both those things by 2. And it turns out actually, the gradient is 7, so that is also parallel to that line. Okay, straight line graphs then, y equals mx plus c. And nth term. Okay, let's take a look at these. Two sequences. One that's going up in 7s, 7, 7, 7. One that's going up by a different amount each time, 3, 5, 7. Two different ways to do this. If it's going up by the same amount each time, whatever it's going up by times its n. If it's going up in 7s, it's 7n. If it's going up in 4s, it's 4n. Then work backwards a number and pretend you're coming down this sequence and ask yourself what number would have been there if they were a number. So if I'm coming down in 7s, the number that would have been there is minus 4 and tag that on the end. That's the nth term. If they're going up by a different amount each time, the totally different method. What you need to do is you need to write out what n, this will be something to do with n squared. So n squared, if it were n squared, the first term would be 1 squared, which is 1. The second would be 4, 2 squared. The third would be 9, 3 squared, and then 16. Ignore that for a minute. So the n squared sequence is 1, 4, 9, 16, but my sequence is 3, 6, 11, 18. And hopefully you can spot, hang on, every number here is 2 more than what n squared is. So if this is n squared, this is n squared plus 2. Right, let me just hang up on that person. I haven't got time to re-record this. Okay, how does that apply up here? Alright, let's have a look at these. So my equation, if you can see this hopefully, is 7, 11, 15, 19. It's going up in 4s, so I write 4n. What number would have come there? It would have been plus 3, 4n plus 3. Next one. This one's going not up but down. It's going down in 2s, so it's minus 2n. What number would have come there? It's plus 74. Minus 2n plus 74. The next one, it's changing. It's going up 3, 5, 7, 9, whatever, okay? So I write out the n squared term, 1, 4, 9, 16, 25, and then I write what I've actually got underneath, minus 7, minus 4, 1, 8, 17. You might notice that every number in the sequence I'm talking about is 8 less than the actual number. So this sequence here is n squared minus 8. And finally, unfortunately, there is going to be a part 3. It'll be a shorter part, okay, because we're going to end with this. And finally, it's giving me the nth term. It's telling me what the sequence is. It's 3n squared plus 4. And then it's asking me, what's the 20th number in this sequence? If you want the 20th number in the sequence, swap 20 instead of n. So it becomes 3 lots of 20 squared plus 4. Remember BIDMAS though. Indices first. 20 squared is 400. Then multiply by 3, so 3 times 400, which is 1,200, and then finally add the 4 on the end, so 1,204. That's the end of part 2, and we'll come back for part 3.